Monday, Wednesday आपका batch रहेगा, and according to Indian time it is going to be 6:30, and according to your time it is going to be 4 o'clock. Okay. So today we'll start solid state, and now one more thing is that, so whatever I will be teaching today, I will ask, and you will have a viva on the next class. Okay. And all the marks will be noted, and then as a sum or as an average of a week or of 2 weeks, it will be sent as a report, like to the account or to your parents. Okay. So we will be starting with solid state. Achha, one more thing, every Sunday you will have a test. Okay. Sunday you will have a test. So Sunday we basically follow MCQ, then viva. Okay. And then there is subjective, and then there is MCQ. So the first week of the month MCQ, second week will be viva, third week will be subjective, the fourth will be MCQ. Okay. Fine.
Yes. Okay.
Okay. And have you registered in the web portal or the app anywhere?
No, actually, I'm just trial. This is just a trial. I'm just trying to.
So just the trial. That's okay. Okay. So in solid state, we will start with a shape that is very much and very often found inside in solid state, as a pattern that you will be often meeting in. Okay. And that pattern is something you have already seen. It is a cube. So today what we'll do, we will learn and we will focus more on the cube, because whatever we are learning today now, this is the base of everything that we are going to learn in the next class. So the first class and the second class are the most important. Now, and after that, so the first class and second class I just teach, and after that you just answer me. Okay. So I will have been taught the basics of each and everything. I will be giving you hints here and there after the second class, but most of the things of solid state, the conceptual part, that will be done in the first 2 classes. So please pay very much attention, and also try to remember everything that I will teach you in the first 2 classes. Okay. Don't forget anything. Don't forget anything of the first 2 classes. These are very important. Okay. So I'm making a cube, and I'll ask you a few questions about the cube. Some of them will be old questions, and some of the questions about the cube will be new to you. Okay. So in this cube, tell me, how many corners are there? Yes, Kulsum. How many corners are there? Acha, you're not sure? Kulsum, you're not sure?
8.
8. Acha, okay, fine.
I'm
Acha,
sorry,
before
my
that,
mic was muted.
Acha, your mic was muted. Okay. So what are your subjects, by the way? You have physics, chemistry, and
Maths, bio.
maths. Maths, bio.
Yes.
Why? Why maths, bio, both?
I'm quite good at maths, and bio is like kind of an interesting subject for me.
Bio is like a
Kind of an interesting subject for me.
Acha, interesting subject to you. So what do you want to pursue after 12th standard, by the way? What do you want to do?
I'm still decided on that.
Acha, you are still deciding on that. Okay, fine. So have you decided what you don't want to do?
Yeah, I don't want to do engineering, that's for sure.
Oh, you have so much passion, huh? Engineering nahi karna. Why not engineering?
I'm not good at physics.
Not good at physics. Okay. Fine. Okay. So you're looking in between. Okay. Now you have medical is a big choice there that you can easily make. And you're looking at other options also.
Yes.
Like BSc and all?
Yeah, kind of like that.
That's a kind of like that. So if you will do BSc, then you will do in maths, BSc in mathematics?
Maybe in maths. Yeah, I'm
Maybe in
deciding.
maths. Just deciding. Okay. The corners you said there are 8 corners. Okay. Do you have any interest in computer science?
No.
No. So like you have not even explored that side of yours, like whether do I have interest or not interest, because it's very much like maths.
Computer science? No, I have still not explored that.
Actually, you have not explored that. Okay, fine. After corners, you tell me how many faces are there?
6 faces.
6 faces. And how many edges?
12.
There are 12 edges. Very good. Now, so these are the old things. The new thing that you have here is how many diagonals are there?
Can you hear me?
Yeah, I can hear you.
Yeah, 12 faces, so 12 diagonals, right?
6 faces, so 12 diagonals, you're saying, right?
Yeah, sorry, 6 faces, 12 diagonals.
So you're saying that we have a face and each face has 2 diagonals, right?
Yeah.
That way. Okay. So you understand that a diagonal is a line joining two opposite corners, right?
Yes.
Okay. Now what you said was, Asha, if I talk about, let us say, wait a second, let me. Okay. You look at this point here. So this is, can you see that this is the front wall?
Yes.
Okay. Front, and this is the top right.
Yeah.
So the opposite of this will be back, bottom left, correct?
Yes.
So that will make this is the front wall. So this wall that is will be back is this wall. So this wall, and in the bottom, so we have bottom, and then we have got to left. So this is the point, right?
Yes.
This is the point, है ना? So the line joining these 2 points will also be a diagonal, correct?
Yes.
Because these are opposite. So, but what type of diagonal is this then? So we are not having a face diagonal. This is not a face diagonal, right?
No, this is not a face diagonal.
This is not a face diagonal. This is not in the face, but it is there inside the cube. And we can say that it is passing through the body of the cube. Hence, it is a body diagonal.
Yeah.
Okay. So in diagonal, we have 2 types. In diagonals, we have 2 types. We have a face diagonal, and there are how many face diagonals? There are 12 face diagonals. Hai na? 2 in each face. 2 in each face. And if I talk about the body diagonal, then for body diagonal, acha dekhiye. When you were talking about the face, you had a square. You had 4 corners, and hence you had 2 diagonals, right?
Yes.
Hai na? And these 2 diagonals were inside the body of the square.
No.
Correct? No, inside the body of the square. Inside the
body.
got
Yeah.
square, right? Inside the square. Now, when I talk about the body diagonal of the cube, then what I will look? I will look at the corners of the cube. 8 corners. Hai na?
Yes.
So how many body diagonals?
4 diagonals.
4 body
4
diagonals.
body diagonals.
Hai na? 4 body diagonals. Fine. So 4 body diagonals, and you can see that if you choose these 2 points, so there will be a from top to down like this. There will be another from here to here, right? And there will be another be from here to here, and there will be another that will be from here to here. Okay, so it's kind of not very easy to visualize in 2D space, but there will be 4. You can imagine it at least. Okay, you can imagine it like that. If you choose the starting 2 walls, these 2, then these 2 points will have 1 point here, and the other will be here, right? If you join these 2 lines, then you will get a body diagonal. And if you join these 2 lines, green line and this green points, then you will get a body diagonal. And if you join this yellow and this yellow, you're going to get a body diagonal. Okay. So I have marked these points. So this red point and this red point. If you join these 2, you will get a body diagonal. If you join the green points, you will get a body diagonal. If you join the yellow points, you will get a body diagonal. Fine. Now, let me also make the face diagonal here. So this is the face diagonal, correct?
Yes.
Okay, let us suppose that this edge length is A. Okay, this edge length is A. So this edge length here will also be A because it is a cube, right?
Yes.
Now you tell me what will be the length of this face diagonal? Anna, you can calculate this by Pythagoras theorem, yes or no?
Yes, hypotenuse.
Anna, this is the hypotenuse, right? This is the hypotenuse. So we can calculate face diagonal square will be equal to A square plus A square, correct? This will be equal to 2A square, Anna. And then we can write face diagonal will be equal to under root of 2A square. From here, A will come out and you will be remaining with A root 2. Yes, Kulsum, right?
Yes.
Okay, fine. So we have got the face diagonal length is equal to A root 2. Okay. Now I want you to see this particular line. And can you locate this edge in your room? Can you locate this edge? Hannah, you can see that edge in your room also, right? You can see that edge in your room also. And you can see this face diagonal passing in the floor.
Yes.
Hannah? So what is the angle between these two? 90 degree?
Yes.
Acha. Now if these two are 90 degree, our body diagonal will be the hypotenuse. Hannah? See?
Okay, yeah.
Got it?
Yeah.
Hannah, this will be our hypotenuse. Now, our face diagonal is how much? It is A root 2. Its length is A root 2. And this edge is how much it is? A. Now we can also calculate the body diagonal square, which will be equal to A root 2 whole square plus A square, which will give me 2A square plus this root 2 square will be 2 and A square will be A square plus A square. It will give me 3A square. Is that right?
Yes.
And then body diagonal will square. It will be equal to, sorry, let me write body diagonal only. So body diagonal will be equal to under root of 3A square. And this will be equal to A root 3. Hannah? So this body diagonal will be A root 3. Okay. Now these are the information that you cannot forget. Corners are 8, faces are 6. This already you know. A face diagonal, the length of face diagonal is A root 2. The length of body diagonal is A root 3. Okay. So these are the information that you will not forget. You will always remember this. Okay. Fine. Is it clear? Yes or no? Tell me.
Yes, clear.
Okay. Have you noted this down? You want to
Yeah,
note
I've
that?
noted this down.
Okay, you have noted this down. Okay, fine. Now moving on, we are still on cube. We are still on cube. But right now, what I am going to do, I will have a cube. Now I'm making a sequence of cube. Okay. Acha. Let us leave that and let us try to imagine. Okay. So what do you want? You want me to show or you want me to let you imagine? I will give you some clues and you have to imagine some things. What will be more fun? Tell me for you. Imagine.
Yeah.
Okay, fine. So let us not use the board. Okay. Now look at your room and then you point towards the, please, Anna. So please say, no, don't just look. You point towards the, you have a front wall, no? You have a front wall. First of all, tell me that. And then you point towards the top left corner.
Okay.
Okay. You can see the top left corner.
Yes.
So you will have some ceiling like this. There will be a wall like this, right? And you will have a corner here, correct?
Yes.
Now, you will have a room adjacent to this room, right?
Yeah.
So you have this room which is adjacent to this room. Now in that room also there will be the same corner, this corner here.
Yes.
Okay. Now you can have a room in front of the room adjacent to you and a room in front of your room also, correct?
Yes.
So I can show like this. Now this corner is also there in all these 4 rooms, right?
Yes.
Now you can have a room above your room, a room above your adjacent room, and the room in front, the 2 rooms, right?
Yeah.
So the corner is also shared by all those 4 rooms,
Yes.
so you have this corner, you have this one corner, it is shared by 8 different rooms, right?
Yes.
This corner is present in 8 rooms. Yes, hello Kulsum, are you there?
Yes. Yes. Yes.
Okay. So corner is shared by 8 rooms, or here we can say 8 cubes. Okay, corner is shared by 8 cubes. Now, if I have anything, if I have a corner and it is shared by 8 rooms, then what is the contribution of corner in one room? Tell me. How much of the corner will be present in one room if it is present in 8 different rooms? If it is shared by 8 different rooms, then in one room, how much of the corner will be there?
1/4.
So you have a chocolate and you have distributed it into 8 friends. Okay. So how much each friend has? 1 by 8. 1 by 8, right? So contribution of corner is what? 1 by 8. ठीक है? याद रहेगा?
Yeah.
है ना? And now you will also remember the way na, if you have to explain to someone how it is 1 by 8. है ना? So this method of contribution is known as sharing method. Okay, sharing method. So this is a particular type of pattern, this cube that you always see in solid. So in the corners there will be some atom present. Okay, and that corner atom will be shared by 8 different rooms, and in one cube its contribution will be 1 by 8, and we'll be using this very often. Okay, we'll be using this information very often. Acha. Next is contribution of. So for the contribution we have to look in how many rooms anything is shared, right? In how many rooms anything is shared. So corner is shared by 8 rooms. Let us look at the face center, faces. Okay. So face. So face means you are looking at a wall, right?
Yeah.
Anna. So wall is shared by your room and the room adjacent to yours, correct?
Yes.
So only 2 rooms, na?
Yeah.
Anna, you can see that. You can see that, na? Bas haan haan bol rahi hain aap.
No, I can see that.
You can see that, na? So in 8 rooms or cubes. So contribution of face in one room is equal to half, correct? If I will place an atom in the face, then half of the atom will be inside one room and the half of the other half will be in the other room. Got it? Okay. Now, if I will place, let us look at the edge. Okay. Let us look at the edge. So you have one edge of one room here like this. So let us look at this edge here. Okay. Let us look at this edge here. Now this edge will be shared by the other adjacent room, right?
Okay.
This edge will be also there in the adjacent room.
Yeah.
And then you will have 2 rooms just above these 2 rooms. And in that room also you will have the same edge, correct?
Yes.
So you have edge is shared by how many? Edge is shared by 4 rooms. Okay.
Okay.
So edge is shared by 4 rooms or cubes, and hence the contribution of edge in one room is equal to 1 by 4. Okay. Now, if let us suppose an atom is present inside the unit cell, okay, this is also sometimes called as unit cell. We will see what is a unit cell in detail, but rather we will say in a cube now. So if it is present inside the cube, then we will say that it is present in the body center. Okay. It is present in the center of the body, that is the cube here. So if the body center, then the contribution in one room, it is equal to 1 because the complete atom or the complete thing is inside the cube. Got it?
Can you please explain body center again?
Acha, you have an atom inside the cube.
Yeah.
Okay, so you have. So then it is 1 only, na contribution.
Okay.
It is not shared by any other room. Got it? Okay, so these are the another things that you have to remember, the contributions. Okay, is that clear?
Yes.
Okay, so corner is 1/8, face is half, edge is 1/4, and body center is 1. Corner 1/8, edge is half, edge is 1/4, face is half, and body center is 1. If you have any doubt, just imagine and look at your room, है ना? एक फ्लोर से दूसरे फ्लोर भी चल जाइए अगर हो सके तो, and look what are the rooms sharing a particular edge, a face, or a corner. Okay.
Okay.
Now I have a question for you. Now we will move into solid state. So what we were revising and reviewing cube, and we were reviewing also some other portions of cube that will be learning in this chapter. But now let us start with solid. And the question is, the first question that I want to ask is, what do you think? Is there any vacant space in solid?
Yes.
Is there any vacant space in solid? Yes or no?
In a solid. No,
In a
there is
solid.
no vacant space.
There is no vacant space. Okay, fine. Now I will ask another question. What do you think? Okay, please remember this is what do you think? What do you think is the shape of an atom? Tell me.
Shape of an atom.
Shape of an atom.
Can take any shape, right?
Any shape. क्यों भाई?
No,
Hmm?
I don't understand what you are trying to say.
I'm trying to ask. I'm not trying to say anything. Shape of an atom. You have seen photos of shape na in your
Yes.
textbook.
Circle, circular shape.
नहीं तो लेकिन रियल वर्ल्ड में क्या हो जाएगा? वही सर्कल
No, sphere.
है ना?
Yeah.
Got it?
Okay.
है ना? So we can approximate, like this is the best approximation that we can make. That is why ना atom का radius होता है कि नहीं होता है? You have atomic radius ना?
Okay. I understand.
है ना?
Okay.
तो फिर ठीक है. Sphere है ना?
Yeah.
Okay. And you may have not seen, or you may have seen a block of iron. You have seen a block of iron. देखा नहीं होगा, but you can imagine ना, there can be a block of iron, है ना? ठीक है? So a block of iron will be a cubical shape or cuboidal shape, right?
Yes.
Like the shape of your room.
Yes.
And the atoms inside, let us say this is iron, so we have Fe, and inside this block we will have Fe atoms, and those will be, you can imagine in your room, footballs.
Okay.
Now you fill your room with football. Will there be vacant space or there will be no vacant space?
There will be very less.
Will there be vacant space? Yes or no?
No, there won't be any vacant space.
There would, you will fill the complete room with football. There will be no vacant space.
No,
You don't have to.
No.
You don't have to cut the football. You cannot cut the football.
Okay.
Okay. Still, you can fill the whole room without any space.
Yes.
अरे ऐसे कैसे? अच्छा, let us imagine. अच्छा, we are filling footballs inside a cube that is equivalent to filling this rectangle with circles, right?
Yeah.
है ना? Equivalent. Both the things are equivalent, na? We fill football inside a cube or we fill circle inside a square, right?
Yeah.
So you have this square, this circle here. So you can completely fill this square with circle. There will be no vacant space.
There will be some vacant space.
There will be na. There will be vacant space na. Hmm?
Yeah.
That's what I am asking. Is there any vacant space? I have asked na.
Okay.
Is there? है ना? So there will be, yes. So answer is yes. This is the starting of our chapter. है ना? So solid कहाँ से start हो रहा है? जहाँ से solid नहीं है. So where are we starting solid from? We are first of all studying what is not a solid. है ना? Inside the solid, what is not a solid? What is the vacant space inside the solid? First we will understand that. And these vacant spaces, these are known as voids. Okay. So this is the first term that you have to remember. The first term, void. Okay. What is a void? So let me first of all write the definition, and because void has two different names, so I write the vacant space. The vacant space inside a solid is known as, or wait a second, is called void. called void. There is other name for that, interstitial site. Okay, the vacant space inside solid, it is known as what? It is known as void or interstitial site or interstitial sites. So please write this point, the only one point, okay, this one line.
Okay. Done.
Done. Okay. Now, everything that you see in the world around you, it is 3D, right? But let us see the lower dimensions first. So you are good at mathematics, so you will say, what is the dimension of a point? How many dimensions are there? One. What is the dimension? What are the dimensions, by the way? There's a length, breadth, and height, right?
Okay, yeah.
So point is dimensionless, na?
Yeah, point is dimensionless.
Completely dimensionless. It has 0D. It has 0 dimensions. Okay. And if I take two 0-dimension objects and I join them, then what will I get? I will get 1D, a line. Hannah?
Yes.
And if I take two 1D objects, I am taking two objects that those are 1-dimensional. And what I'm doing, I am joining them. Then what will I get?
2-dimensional.
2-dimensional object. And if I take 2-dimensional object and I join them, what will I get? 3-dimensional. So if you ever study mathematics further, you can study 4-dimensional objects also, na? कैसे पढ़ेंगे समझ में आया?
Yeah, good.
Then you will also study 5-dimensional. Then mathematicians, they go crazy, they study n-dimensional geometry, in which you have n dimensions. The infinite dimensions are there. Okay. But the important point is that in order to study higher dimensions, you have to know things about the lower dimensions. And because the higher dimensions are made up of lower dimensions, right?
Yes.
And so our goal is to study the 3D solids in the real world, and we have to understand the real world. That is why you are studying the solids. But we will have some portion of 2D also, so that we have a good understanding of 3D and we can transition from 2D to 3D very easily. Right? So when we have to study 2D solids, in 3D solid, there will be 3D voids, and there will be 3-dimensional voids. And if you want to study 2D solids, which are imaginary, there is no 2D solid in real life, which are imaginary, that we are studying only because we have to have a good understanding of 3D, so we can transition to 3D very easily. Now, when we are studying 2D solids, there will be 2D voids and there will be 3D voids in reality. Got it? Yes or no?
Yes.
So we will study voids, and there will be two types of voids that we will be studying. There will be a 2D void, there will be 2D voids, and there will be 3D voids. Okay. Now these voids will be made by atoms, no? Because when we are joining atoms, we will be making solid, and inside the solid there will be voids. So obviously these voids, they will be made by atoms. Now there should be a way to represent atom. There should be a way to represent atom. And what I will be choosing, I will be choosing this circle here. But this is a very special circle. Okay. This is a very special circle. Now you tell me, is there any difference between A and B?
Yes.
What is the difference?
One is 2D and one is 3D.
So the A is this here, what I have drawn, it is a circle. Yes. And the B is a sphere. Very good. B is a sphere. Okay. Now, if this is a circle, we will be talking about the space occupied by circle, and that is equal to area, which will be equal to pi r square. And also remember, when we talk about the space occupied by sphere, which is a volume, and this will be equal to 4/3 pi r cube. Correct? Now we have set the ground. Let us now learn about the first void. Now, I will not give you the name. You will tell me the name. Okay? I will just tell you how the voids are named in general. How the voids are named. So I have taken 3 atoms and I have joined them like this. Now, how to name this? Can you see the void here? You can see the void now. This is the void.
Yes.
This is the void. Now, how to name this void? So to name the void, what we do, we take the midpoints of atoms. What do we take? We take the midpoints of what? Atoms that are making the void. Okay. Okay. And we join them. So we get a shape. What is the shape?
Triangle.
So this is triangular void. Easy. Hannah, easy.
Yeah.
Hannah, triangular. Now there is a term, a new term. Hannah, now we have a new term. Coordination number. Coordination number. Now this term as a whole will be new, but you may have heard this word. Can you please coordinate with your friends and do this thing? Can you please talk to your Hannah? So coordinate. So when you have this coordinate, now that means how many friends are you in touch with, right? Hannah?
Yeah.
So you can say that if I ask the coordination number of anything, then the question it is rather asking how many atoms does it touch?
Okay.
What is it? It is the thing of whose coordination number I am asking. Okay. It can be anything. It can be a void. It can be an atom. But this question will be same. If I'm asking the coordination number of the void here, then I'm asking how many atom does the void touch? And how many atoms does the void touch? So here you can see now what is the coordination number for this void?
3.
3. Now for void, it is going to be very easy. The coordination number of void is always equal to the number of atoms making the void. Okay.
Okay.
So this hash sign, it is used for numbers. You know that? No. Number of atoms making the void. Okay. So this is the first void that we have studied in 2D. Now let us study the second void. So again, here also I will be just drawing the void. So basically now there are only two ways in which you can have a 2D arrangement of atoms. Okay. So this is the second arrangement that you can have. You can see a void here also.
Yeah.
How will you name the void? Tell me. You'll join the midpoints.
Square void.
The square void doesn't sounds proper, so they have
Yeah.
named it square planar void.
Okay.
है ना? थोड़ा सा तो अजीब आपको भी लग रहा होगा बोलने, है ना? So they have named it square planar void. Now you will say the coordination number. Tell me what is the coordination number?
4.
So ऐसे ही चलेगा. See, you see now you have been starting. You are starting to answer things. So after 2 classes, everything will be you will be answering everything. Okay, I will be not teaching anything. You will be answering everything. Now 3D voids. Let us come to 3D voids. In 3D void, first void that I will be making, it will be, we will take this base of 2D. Now, as soon as I put it here, these circles, they are now triangle. Sorry, these circles, these are now spheres, है ना?
Yeah.
है ना?
Yeah.
So you can assume that we have 3 footballs on the floor. ठीक है? 3 footballs on the floor. Okay. Yes or no?
Yes.
Okay. Then what do? I add another football on top of it. A red football on top of 3 black football. Okay. So there will be a void.
Yes, there will
Anna?
be void.
There will be a void. There will be a void. So you can see that there's a blank atom here. There's a black atom here. There's a black atom here. And on top of these 3 atoms, we have a red atom here. Anna?
Yes.
Can you guess what is the shape? What is the shape of this void? What is the name of this void?
Pyramidal.
Pyramidal. Okay. अच्छा, हम इसमें थोड़ा सा आपको ध्यान लगाते हैं. Let me try. Now you tell me. You have seen this type of shape now earlier in chemical bonding.
Yeah.
What shape is this? Tetrahedral, no? You remember? है ना, टेट्राहेड्रल void, टेट्राहेड्रल void. अच्छा, so tetrahedral, now this tetrahedral means 4 faces. Okay, this will have 4 faces. So actually you remember it like this, the geometry like this tetrahedral, but the shape, actually what the tetrahedral shape is like this. It has, so we have got one face, है ना?
Yeah.
Now we have got 2 face. सही है ना? 2 ही face हुए ना अभी तक तो.
Yes.
Now you see, as soon as I will join this one line, I've got the 3rd and 4th face also, है ना? एक तो ये वाला और एक पीछे वाला, ठीक है? That is why it is named as tetrahedral, 4 faces. Okay, but you are more acquainted with this shape of tetrahedral. That is why I'm making this shape. Okay, but the way I have mentioned now to join the midpoints, it remains same. You will join the midpoints and you will get a tetrahedral shape. You will get a tetrahedral shape. Achha, what is the coordination number here?
4.
4. Very good. The next is void. That is, so I will take these atoms. And I will put 4 atoms just on top of these 4 atoms. Okay, so I have 4 atoms, 4 footballs like this, and just on top of the 4 footballs, I'm keeping other 4 football. Okay, I've made the size of red ones a bit smaller so that you can see that they are kept on top of the black ones. Okay, fine. Yes or no?
Yes.
Okay. Now, for this, what do we have? Here we have a layer. The first layer is black layer, right?
Yeah.
The first layer is black. So this is the black layer that I have made. And just on top of that black layer, I have a red layer. सही है?
Okay.
है ना?
Hmm.
So we have atoms here in the black layer. And we have atoms on the red layer. And if I join this 2 layers, I will get a cube, right? So this is a, so what will be the void's name? It will be cubical void, है ना?
Okay.
Because we have got a shape. We have, see, these are the midpoints, है ना? वो हम तो 3D बना नहीं सकते यहाँ पे, है ना? I cannot make here, ना? That is why I have taken out the midpoints and joined them. Okay, so we have got cubical void. What will be the coordination number here?
8.
8. Very good. Now the third void. This is the most important void. Okay. So let me take this 4 atoms and get rid of the red ones. Okay. Now earlier we had taken the footballs and we had kept them in the floor. But right now what I am doing, I have got people who are holding these footballs above the ground. Okay, they are holding these footballs above the ground. Can you imagine that? Yes or no? Okay. So if they are holding them above the ground, then I can take another atom and I can keep on top of them. Yes or no? So that I will show like this. So we have got this red atom and I have kept this on. I've got this red atom and I've kept this on top of black atoms. Okay. Okay. Similarly, what we can do now, these are not, these black atoms, these are not on the ground, these are above the ground, and hence what I can do, hence I can take another red atom and I can keep it from below also. We can stack it right from below. Yeah. So this is from below. Okay, this is from below. So the shape that you will get is you have 4 atoms like this. And then you have a red atom here. And then you have a red atom here. So do you remember this shape? ऐसा shape याद आया? What did we say? What is the geometry here? SF6. नहीं याद आया. Tell me.
I don't remember.
Octahedral, na? Remember now?
Octahedral.
Octahedral, right? This is octahedral. What will be the coordination number here?
5.
Huh?
666.
6. Coordination number will be equal to 6. Okay. Now I want to show you a different perspective. I want to show you the octahedral void from a different perspective. Okay. So can you see this black screen?
Yes.
So I've got sulfur. I have to change these to fluorines first. Okay. So you can see now, you can assume that these are the 4 layers. Sorry, these blue ones and these 2 red ones. They are in one layer, and then one above, one below, and this yellow thing is the void. Okay.
Yes.
Okay. But if I change the orientation, so I'm just changing the orientation of how these look. So yellow is the void. Yellow is the void. Okay. And I hope you can see that if I join the midpoints of the 3 behind one, so they are all in one layer, and all these red ones are in one layer, correct?
Yes.
And all of these blue ones are in one layer, right?
Yes.
Okay, the red one is making a downward triangle.
Yes.
And the blue one is making an upward triangle.
Yes.
Right? So if you see this type of, if you see atoms in this configuration, that in one layer they are making a upward triangle, and in the other they are making a downward triangle, then that is also a octahedral void. Right? This is octahedral, but we are seeing this in a different orientation. We are seeing them in a different perspective. So I want to put this perspective also here. Okay, let me reduce the size. So what I have seen here is, if I join this red line, I will get a triangle. And if I join this blue lines also, I will get a triangle. That means if I have something like this, okay, and we have atoms like this in one layer. Okay, this is in one layer, all the 3 atoms that is making a downward triangle in one layer, and there will be some angles making an upward triangle in the next layer. So this is also octahedral void, right? Yes or no?
Okay.
Okay, yeah, samajh mein aaya.
I got it.
Got it, na? It's just that you have to remember this is also one of the orientation in which you can see the octahedral void. Okay.
Yes.
So we are done with octahedral voids and everything. And now we'll start with solids. So solid is basically you have to, okay, even if you like search for the word or look into the dictionary in a solid. So solid is anything that is 3D. Okay. So basically this word solid in mathematics is for 3D things. But first we will start with 1D. Okay. We'll start with 1D. And we'll start with one atom. That is our point. Then we will take a sequence of atom, and then we will start putting atoms right? On next two atoms, we'll put atoms next to atoms, and then we'll make a 1D solid. We'll make a 1D solid. How will we make a 1D solid? See. अच्छा, आपने लिख लिया ये सब ऊपर का?
Yes, I got it.
ठीक है. Okay. So we have a atom here. Okay. And I will place another atom here. I will place atoms in one dimension only. है ना? See? Right?
Yes.
So this is our 1D solid. Okay. What is this?
1D solid.
है ना? This is 1D solid. If we will have a solid, this is imaginary, but still this is 1D packing. What we are doing, we are packing the atoms. है ना? This is 1D packing. If the atoms are packed in one dimension. Now, I want your focus on these two atoms. Acha. We can put more atom adjacent to these two atoms, right? If I am still in 1D packing, I cannot go 2D. Okay, I have to put atoms in 1D only, but still I can put atoms adjacent to these two atoms, right?
Yes.
Hannah? But what about these atoms? Can I put any atom adjacent to these now?
No.
No, no. So their environment is complete,
Yes.
right? So essentially, now what I can say, these like the corners, like the extreme ones, the extreme atoms, these are not complete, right? These are their 1D packing is not complete. We can put more atoms, but the middle one, their environment is complete, right? Their environment is complete. And whatever question is asked about any packing, 1D, 2D, or 3D, they will be asked only of those atoms whose environment is completely made, So the first question that I will be asking here, what is the coordination number of atom in this 1D packing? So when I say coordination number, what do I mean? How many atom does it touch? So you will take any one of these atoms. So let us say I took this atom. Okay. You can take any atom and tell me how many atom is it touching?
2.
2. So the coordination number is 2. Okay.
Yes.
Fine.
Okay.
Okay. Now what I will do, wait a second. Now 1D is done. So there is only one question that can come from 1D solid. That is, what is the coordination number of 1D packing? And you will answer it 2. Now I want to move on to the 2D packing. So now I will take this atoms. I will take these atoms, and what I can do, I have got the length. I will add atoms in from below like this. Hai na?
Yes.
So this is now 2D. It has got the width also. But I see that I have a choice. I can put either atom on atom, or I can put atoms on the depression. Hai na?
Yeah.
Can you see that? Two choices. I can either put the atoms like this. Now you can see that these arrangements are different. Hai na? If I put the atoms like this arrangement is different. The solid is going to be different. And if I put the atoms just below the atom, then it is a different solid. Correct?
Yes.
So what I will do, I will say that there are two types of packing that I can have. If I go from 1D to 2D, so from 1D packing, I'm going to 2D packing. Now in 2D packing, I can say that there are two different types. So there will be a packing which will be made by atoms on atom. There will be another packing which will be made by atom on depression. You understand depression, na?
Yes.
बीमारी मत समझ लीजिएगा, है ना? Anxiety वाला depression नहीं, okay?
No.
हाँ. एक तो I don't know why your whole generation is so sad right now. Why are you guys so sad?
I am not sad. I am
Not you.
normal.
You're normal. But no, I am talking about your whole peer group, your whole age group.
Probably because of the stress and pressure. In
Wow.
older times, I don't think there was that much stress on education.
अच्छा, तो पढ़ना नहीं है आप लोगों
No,
को?
that is not the sole reason though. There are many reasons.
Wow, very nice. है ना? क्या माँ बाप खट मर के पढ़ा रहे हैं, उसी से बच्चों को इतना पढ़ना पड़ रहा, बताइए. है atoms on depression. But you know what? See, atoms on atoms, it is not good, and we will prove this. Atoms on depression, they are more efficient. Okay, not saying that one should be depressed, but atoms on depression are more efficient. We will see how. You joined for a while, na, when the last class was going on.
Yes.
तो did you hear that I asked which solid is better?
Huh?
नहीं, no, you did not hear which solid is better. अच्छा fine.
No,
Okay.
I thought I joined the wrong class.
अच्छा, you thought you joined the wrong class. अच्छा. So atoms on atoms देखते हैं पहले, है ना? So we have atom, and then I will put atoms on atom like this. Then I will take these atoms. अच्छा, जैसे हम बना रहे होंगे, you can see the void ना?
Yeah, I can see.
है ना? I don't have to tell the void also, right? You have this 2D, so you can see that from 2D कौन सा void है, right?
Yes.
अच्छा, now we will do one thing. Let me take a bit of atoms from here. I don't need this many atoms, and I will use this space to name this. I will name this layer as the A layer. ठीक है?
Okay.
Okay, this layer is the A layer. Now, the first layer and the second layer, they are indistinguishable, na?
Yes.
है ना? So this will be also A. The second, third, all this layer, these are indistinguishable. That is why this will be all A, है ना?
Okay.
Right? So this is known as AAA type packing. है ना? We cannot always say ना atoms on atoms वाला packing कर रहे हैं हम लोग. So we have given this a name AAA type packing. AAA type ही रहने दीजिए, packing समझ लीजिएगा आप, ठीक है? AAA type. Now moving on. We have atoms on depression. ठीक है? Atoms on depression. Now here what you can see, here you can see that this is the A layer, है ना? This is our A layer, but this second layer is different than the first layer, right? They are distinguishable. They have slightly tilted, slightly they are moved towards the right, है ना?
Yes.
They are not on top of each other. So this will be B layer, but you can see that this layer and this layer are same, है ना?
Yes.
So this is
A.
again A, and this is same. So this will be B. ठीक है? So this will be AB type. रटने का नहीं है ना कुछ?
No.
है ना? तो ये यहाँ मेरी यहाँ से केमिस्ट्री क्लास पढ़ के घर जाके मत बोलिएगा रटने का है यहाँ पे सिर्फ, ठीक है? So chemistry is not like that, but still, yeah, I will say that chemistry is it is tough. ठीक है? It is tough. Chemistry is tough. आसान बोल के उसको कुछ ये नहीं करना है. Do you play any video games? हाँ, कुलसुम?
No, I don't.
You don't. Have you ever played any video game?
I have played when I was very small.
अच्छा वो एकदम small. But still, you know what is the experience to play a video game, ना?
Yes.
So what do you think? कौन सा video game बच्चे ज्यादा खेलेंगे? जो आसान है या जो tough है?
Easy ones.
Easy वाला खेलेंगे बच्चे.
Kids will play easy ones.
Not kids. Like एकदम ऐसे नहीं कि वो बच्चा बोलना भी नहीं चालू कि आप उसको खेलो.
Okay.
No, I'm talking about the people who have friends.
Yeah, they will play hard ones.
है ना? और
Yeah.
पढ़ाई क्या करेंगे? आसान करेंगे या हार्ड करेंगे पढ़ाई?
Easy.
Why is that? Why is
That
that?
I
है ना?
don't know.
है ना? One should think about these things. है ना? We should make they should develop courses like video games, है ना? So that student they will go and study hard subjects and they will brag with their friends. कि आज तो भाई हमने you know there is NCERT exemplar, right?
Yes.
है ना? हाँ, आज तो हमने exemplar फोड़ दिया. सारा level सारा. They should also as in level 1 exercises should be names like this, level 1, level 2, है ना? And then there should be a grand big enemy. ऐसा villain type बना के रखना चाहिए. है. वो सब फालतू बातें ऐसे नहीं करना चाहिए. One should study
Then
seriously.
they will
Okay.
not learn at all.
हाँ, I know. Fine. So here we have AA type and AB type. Okay, AA type and AB type. Now here you can first of all very easily point out the void. So void is what? Here it is square planar void. And what is the void here? Tell me.
Triangular void.
Triangular void. Okay. Now when I ask anything about this whole packing, then please remember आपको बस इतने ही you have to see just these atoms, because these are the atoms whose environment is completely made, है ना? The other atoms, we can add more atoms, right, left, top, down.
Yes.
है कि नहीं? And also, if I are talking about any of these things from here, then you have only these atoms whose packing is completely made. सही है? है ना? Okay, fine. So if I ask the coordination number of atom in AAA type packing, then what you will do? You will look at one of the atoms whose environment is completely made, है ना? So we will choose this atom. And now you tell me what is the coordination number of this atom?
4.
Very good. ठीक है? अच्छा, now here also I will choose one of these. So I am choosing this. Now you tell me what is the coordination number of this atom?
6, right?
आपने बोला था कि आवाज ही नहीं आई. 6. We have coordination number 4 and coordination number 6. Now, there is one more thing that we have to see. We will not be studying the whole packing. ना इतने सारे atoms हम लोग नहीं पढ़ सकते. Then what we will do? We will take a small portion from this whole packing, and we'll take a small portion from this whole packing that represents the whole packing. And if I repeat that small portion in all direction, then I will get the whole packing. For example, I can take this small portion. सही है? And if I repeat, if I copy paste this whole small portion in all the directions, then I will get the whole packing, है ना? है ना? Similarly, what I can take, I can also take this one. सही है? Right?
Okay.
है ना? You can take this one also. Now here, if I go AB type, I can take this small portion, triangular portion, and if I repeat this small triangular portion in all the direction, I will get the whole packing.
Yes.
Right? I can also take this parallelogram type.
Okay. Yeah.
No, I can also take this parallelogram type of shape, and if I repeat this, I will get the whole. But see, these are all known as unit cells. Okay, these are all known as unit cells. So you may see that there is a definition of unit cell, that is the smallest portion of the packing that, when repeated, it makes the whole. है ना? So here the students, they often. अच्छा, wait a second. Let me show you. Wait a second. We are finding unit cell is the smallest portion of the packing, and on whose repetition, what we will get the whole packing. Okay, but please don't focus on the smallest part. See, if I take this rectangle, है ना? I take this rectangle and I am copy paste. Okay, I took one rectangle and then I copy pasted the another rectangle. Then I took another rectangle and I copy pasted it. So now this rectangle is making the whole packing. Hence, the smallest portion will be rectangle only, right?
Yes.
But the same packing can be made by this unit cell also. Oops, sorry, eraser aa gaya. The same packing can also be made by this square unit cell, है ना?
Yeah.
And in that case, the smallest portion will be square. Okay. So all of it is not that this is unit cell or that is unit cell. Each of them is a unit cell. Okay. Each of them is a unit cell that you can take. But what we are going to take, we will only take one unit cell. And now the unit cell that NCERT has taken, and why they have taken that also I will tell you. So NCERT has taken for AAA type a unit cell, which is this unit cell. So they have taken a weird arrangement. One should always see things and they should ask why they have taken this unit cell. We had simpler shapes, but they have chosen to take a very weird shape, that is this. Now, if I repeat this also, then I will get the unit cell. Then I will get the packing. But why this? है ना? Why did they choose this unit cell? Which is kind of weird. Now, the reason that I came up, it is that this unit cell, now, it's kind of unique. It tells me about the coordination number. है ना?
Yeah.
The other unit cell, they do not tell me about the coordination number, correct?
Yes.
है ना? So this is special about this unit cell, that it tells me about the coordination number. So this is the unit cell that we will be studying. Okay. Now in this ABAB type, so I will make the, okay, it's kind of difficult to make this type of shapes, and that is why I will make here. OneNote is going to help me. See, I am making very weird shape, but OneNote will adjust this for me. See, thank you, OneNote. And I will place it here. Now this also, if I take this unit cell is also telling me the coordination number, and it is giving me the information of coordination number, right?
Yes.
Okay. So I will have this as the unit cell. Yeah. Right. So we have got the array. Again, got blue, black. Okay, fine. We have got the unit cells also here. So unit cell. Smallest. Let me write like arrangement of atoms. Of atoms that when repeated forms the whole packing. Okay, forms the whole packing. Okay, both of these things are clear here, right?
Yeah.
Okay, we have got void, we have got coordination number, so we can also write the unit cell. What is the unit cell here? It's a square. And what is the unit cell here? It is a hexagon. Okay. Now, since the unit cell is a square, na, so this packing is also named as a square close packing. Okay, and this is known as SCP. Okay, SCP in 2D. And ABAB type is known as hexagonal close packing. So H is for hexagonal close packing in 2D. Okay. So these are other two names for AAA type and ABAB type. Is this clear?
Okay.
Now the question comes, we have two choices now, which is better? Okay, which is better? So the comparison of solids, now it is very similar to the comparison of students. If I will give you two students, how will you compare them? What will you see? If I ask you which is better student, tell me.
Yes.
क्या देखिएगा? क्या देखिएगा?
Can you repeat that?
अच्छा, can I repeat that? Okay, so I am saying the comparison of solids, now this is very similar to comparison of students. Okay. If I give you two students and I ask you who is better, then what will you check? What will you see?
Their marks.
Very good. Very good. Very conventional, very traditional. Their marks. So here also we have a similar thing, and it is known as packing efficiency. Okay. So जिसका packing efficiency ज़्यादा, वो solid अच्छा, है ना? So we look at packing efficiency. Packing efficiency. Fine. Now, packing efficiency. What is packing efficiency? So packing efficiency, it is the, now this is the formula of packing efficiency, okay, that you have to always remember. So this is a generalized formula that you have to always remember. There will be specifics which will be changed according to the unit cell, according to the different type of packing. But in general, what is packing efficiency? Is the space occupied by atoms in unit cell divided by space occupied by the unit cell, the complete unit cell. And if you multiply this by 100, you will get a percentage type of thing as you get with students also. Is that clear?
Okay.
है ना? तो ये क्या हो गया? Marks obtained. Your total marks.
Yes.
है ना? Marks obtained is the what? Marks obtained is the solid part. So as you can see now, so what we will be doing, we will be calculating the space of these parts, these solids part, है ना? And then we will divide by the whole space. ठीक है? So you will get the percentage. ठीक है? You will get the percentage. So if I want to talk, okay, if I want to calculate the packing efficiency, so there is one more word which is packing fraction. Let me write these things first. Packing fraction, it is what? It is nothing. It is just this part without the 100. Okay. So you will get a decimal type of thing for fraction. Okay. So this is what? This is packing fraction.
Okay.
And what you can write? You can write that packing efficiency is equal to packing fraction into 100. है ना? ये important नहीं है, लेकिन बस लिख सकते हैं आप packing fraction into 100 will give you packing efficiency. Okay. इससे कोई सवाल नहीं आएगा, ये कोई फॉर्मूला नहीं है, ठीक है? It is just an observation that you can make, but there is something that you have to remember. There is this void percentage. Okay, so if packing efficiency is the part of, we are measuring the part of solids, then void percentage will be the 100. It is the total space minus the solid part. Solid part is packing efficiency, है ना? तो ये मिल जाएगा आपको कितने मार्क्स आपके नहीं आए, है ना? जो परसेंटेज आपको नहीं मिला है. This will give you void percentage. ठीक है? ठीक है? Yes or no?
Yes.
Okay. Any doubt till here?
No.
No doubt till here. Okay. So first of all, what we'll do, we'll do the packing efficiency of AAA type.
Okay.
Of SCP. है ना? Potential energy मत पढ़िएगा इसको, क्या है ये? P is what?
Packing efficiency.
Very good. Packing efficiency of AAA type. है ना? And it's also known as what? SCP in 2D, square close packing. सारे नाम बहुत important है ना? So please always revise these topics and names. AAA type or SCP in 2D.
Okay.
Now, packing efficiency, it is equal to, now space occupied by atoms in UC, atoms in unit cell, divided by space occupied by the unit cell. And I will multiply this by 100. Okay, so don't write now, okay? A pen, please leave aside your pen. Space occupied by atoms in unit cell. If I want to calculate this part, then what I will do, I can write the number of atoms. If I will calculate number of atoms in unit cell, number of atoms, don't write please, number of atoms in unit cell into the space occupied by one atom, है ना?
Yes.
Yes or no?
Yes.
Into 100 हो जाएगा, or divided by the same thing, that is space occupied by unit cell. Now, number of atom in unit cell, now it has a letter assigned to it in solid state, which is known as Z. So this gives me, Z gives me the number of atoms in unit cell. Okay, multiplied by, when we are looking at AAA type, now let me get this unit cell first, है ना? Unit cell ले आते हैं हम यहाँ से. So ये unit cell आ जाएगा ऐसे. अच्छा. I hope I will get the unit cell. Yes. So you can see the unit cell here, right? See the unit cell here. Now, You can see that not all the atoms of the unit cell are inside. No, not all of them are inside. अच्छा ये छूट गया मेरा एक atom. Okay. So Z into space occupied by one atom. So what is this? These are all circles, right? Yes or no?
Yes.
So the space occupied by circle will be area या volume?
Area, volume. Circle no. Circle is area.
हाँ तो pi r square है ना?
Square is
हाँ
area.
हाँ pi r square हो जाएगा, ठीक है? Right? ओके नहीं बोले, हाँ यस सर बोलो. ओके मतलब ऐसा लगता है कि that you are just agreeing to. Okay. Now tell me, this will be, what will be the space occupied by unit cell? It is, unit cell is what? Unit cell is a square. What is the area of square? Tell me, what is the area of square?
Square. Area of square.
Edge length is A.
4 into.
ओए हाय, ओ क्या मैथ अच्छा है आपका? आपका मैथ अच्छा बोल रही थी आप? हाँ?
No, I didn't understand.
एरिया ऑफ स्क्वायर क्या होगा? अच्छा एक बात बताइए, आराम से है ना, लिख नहीं रही है ना?
No.
हाँ. Space occupied by unit cell. What is the unit cell of square close packing? What is the shape of unit cell in square close packing?
In the square plus packing shape of square.
Square है ना? अच्छा, तो space occupied by square, it will be area या volume? स्क्वायर का क्या होता है? एरिया होता है, वॉल्यूम होता है?
एरिया.
तो एरिया क्या होगा? स्क्वायर का एरिया क्या होता है? 4a है ना?
या.
या 4a.
No, a square.
हाँ, into 100. ठीक है, ठीक है.
Okay.
फिर ओके?
Yes.
ओके नहीं, यस सर. ओके. So here we need to first of all find the z. ठीक है, we need to find the z. ये असल में थोड़ा important है. So I will just move a bit here. I need to see this unit cell at all times. So I will move this here and I will move this unit cell this way. Yeah. Unit cell important है. Now, calculation of z. Z is what? Number of atoms inside the unit cells. Now, listen very carefully. Don't write anything. Listen very carefully. When we calculate Z, the first thing that you will look is the type of atom with respect to position. What did I say? Types of atom with respect to position. Okay? With respect to position. So we have atoms in the corner and we have atom inside, Hannah?
Yes.
See, please remember this line. This will be always repeated. Okay, types of atom with respect to position. So we have corner atom, and then we have an atom that is inside. We have an atom that is inside. Okay. Now, how many corner atoms are there? Please tell me.
4.
4. Okay. Acha. Now tell me, what is the angle that is made by these atom which is present inside the corner?
Degree.
90 degree. Okay. So 90 degrees inside the unit cell, है ना? Right?
Yes.
अगर ये पूरा ऐसे होता, then what is the complete? If I take the whole thing, what is the whole angle?
360.
360, है ना? This is 360. So 90 out of 360 is inside the unit cell, है कि नहीं?
Yes.
So this is the contribution how we calculate. So in Z we have to calculate the contribution of each unit cell, and there are 2 methods to this. Okay. So one we will use in 2D that we are using now, and then one that you have already seen. So in 2D we use the angle method, and in 3D we use the sharing method that you have already seen. आपने sharing method देखा है ना? है ना? Sharing method, ठीक है? So here we use the angle method in 2D. So corner is equal to 90 by 360. This will be equal to 4 into 1 by 4, which will give me 4, and 4 will cancel out, and this will give me 1. And the inside atom, it is completely inside, है ना? देखिए, ये 360 by 360 अंदर ही है सारा का सारा, है ना? So this is what? 1.
1.
Okay. and we will get z is equal to 2 टाइप्स थे, a 1 + 1 हो जाएगा, है ना? अरे हाँ या ना? हाँ,
Yes,
वेरी
yes.
गुड. 1 + 1 which will be equal to 2. ठीक है? Now, even if I let me substitute this value of z here. So we'll get 2 into pi into r square divided by a square into 100. सही है?
Yes.
Now still if I put in the value of pi, I don't know the value of a and r, and I cannot give a particular value for a and r also, because r, that is the radius of a particular atom, it will be differing if I take different atoms. So I cannot give a particular value for r. सही है?
Yes.
But I have to get rid of this r and a na, to get a percentage.
Yes.
How will we get rid of this r and a? कैसे? सोचिए. How will we get rid of this r and a? How will we get rid of this r and a? Now, see, if I listen very carefully, if I write a in terms of r, what did I say? Write a in terms of r. कुछ हम relationship निकाल लें. A is equal to something r. Then what I can do? I can substitute the value of a in terms of r.
Yes.
Then r will also square, and r square will cancel out, है ना?
Yes.
So the next thing that is very important is the relationship between a and r. Relation between a and r. Now, whenever you have to look at relation, okay, whether it is humans or it is atoms, you have to see how much are they in touch with each other. Okay, so touch. Now you have to see atoms touch. Okay, atoms touch. Now you have to look at the atoms. So as you can see, these two corner atoms are not touching each other, है ना?
No.
है ना? These are not touching each other. But we have this diagonal atoms. These are touching each other. सही है?
Yes.
So we will take these atoms, and this will tell me the relationship between a and r. बहुत ध्यान सुनिएगा. You remember the phase diagonal?
Yes.
है ना? Phase क्या था cube में? What was the shape of the phase in cube?
In cube square.
Square था, है ना? और phase diagonal क्या था? What was the length of phase diagonal?
Length of phase diagonal.
हाँ, length of phase diagonal.
Length
नहीं
of
पढ़ा.
one side.
Length नहीं पढ़ा हमने. नहीं लिखा आपने. Length of. No.
Length of phase diagonal. That one. A root 2.
वही बात तो आपने रिपीट किया. लेंथ ऑफ फेस डायगोनल होगी. ठीक है, a रूट 2. तो ये भी तो स्क्वायर है. इसका भी डायगोनल क्या होगा? a रूट 2 ही होगा, राइट?
Yes.
है ना? आ रहा है ना? दिस इज a रूट 2. सी, अभी देख रहे हैं कितना काम आ रहा है. सिंपल थिंग्स, दोस थिंग्स विल बी वेरी मच यूजफुल. ओके, एंड नाउ यू टेल मी, यहां से यहां तक दिस इज r. सही है?
Yes.
रेडियस यहां से यहां विल बी 1r, यहां से यहां विल बी 2r. सही है?
Yes.
एंड देन फ्रॉम हियर टू हियर इट विल बी अगेन r. ठीक है?
Okay.
है ना? सो वी हैव गॉट, ओके नहीं, a रूट 2 इज इक्वल
Yes.
टू 4r. a रूट 2 इज इक्वल टू 4r ना? दिख रहा है?
Yes.
दिख रहा है ना? a रूट 2 इज इक्वल टू 4r. अगर आपने कहा है कि इतना याद करना पड़ता है, कुछ तो इसमें समझने का है नहीं केमिस्ट्री में, तो बताएंगे हम आपको. a रूट इज इक्वल टू हाउ मच?
4R.
4r. है ना? अब हमारे पास सब कुछ है. आई विल सब्स्टिट्यूट. नाउ वी विल कैलकुलेट द पैकिंग एफिशिएंसी, which is equal to 2, which is the z atoms inside the unit cell, multiplied by the area of one atom, pi r square, divided by a square. And what is a? You can write here, a is equal to 4 by root 2r. And what you can do, इसको थोड़ा अच्छे से लिखते हैं, बहुत ही खराब हैंडराइटिंग में लिखा हमने इसको, सॉरी. Packing efficiency, it is equal to 2 into pi r square divided by a square. So this will be equal to 2 into pi r square divided by 4 by √2r we have substituted a, अब इसका होल स्क्वायर ना into 100. I always forget this. Why? ठीक है,
Okay. Yes.
अब आपको लिखना होगा बहुत, अब आपको बहुत कुछ लिखना होगा. कहाँ से लिखना बताइए?
Above.
यहाँ से लिखना है आपको.
Yes.
ठीक है, तो बताइए आप स्क्रीनशॉट लीजिएगा या अभी लिखिएगा? इफ्तार को टाइम है.
Yeah, there is very less time.
वेरी लेस टाइम ना, तो स्क्रीनशॉट ले लीजिए. समझ में आ गया सब कुछ?
Yes, I got it.
अगर स्क्रीनशॉट नहीं लिखेगा तब भी लिख लीजिएगा ना.
I'll write it for sure.
हाँ, है ना. चलिए स्क्रीनशॉट लीजिए, लेकिन ट्राई कीजिएगा कि स्क्रीनशॉट को रेफर नहीं करना है. ठीक है ना. यू
No,
स्टार्ट
I
विद
will
योर, हाँ, अपने दिमाग से लिखने की कोशिश कीजिए. सो
Okay.
याद करने की जरूरत नहीं पड़ेगी. ठीक है, चलिए. लेट मी नो इफ आई हैव टू स्क्रॉल डाउन.
You can come. Okay. Thank you, sir.
ठीक है ना. हाँ, रुकिए, अभी जाइएगा.
No,
ठीक
no,
है,
I'm
साफ
not
कर.
going. I just.
हाँ, ओके. यहाँ पे you will take a highlighter and then you will highlight these options, these conclusions. कॉर्नर 8 ये है, a√2, a√3. ठीक है, उसके बाद contribution of corner atoms 1/8, 1/2, 1/4, h का, body center का 1. ठीक है, and then these are different type of voids. Okay, and then add 1D packing. ठीक है, packing efficiency सब में जो concluding points है ना, void percentage इतना होता है, packing efficiency का definition इतना होता है, जो भी concluding points which are important है ना, that you will